Then what was
Hello, good morning, everyone.
good morning? What was I was out due to medical issues. What was discussed yesterday? Just brief.
Actually, was BGP. We discussed about
Oh,
BGP route reflector.
okay.
Okay.
You didn't discuss about the attributes, how to implement it, right?
No. That implementation will be discussed in CCI Enterprise. How to configure weight and all. So very brief description I will give you here. Okay.
So nothing related with the implementation.
Implementation will be taught in CCI Enterprise.
Okay.
CCI Enterprise. Okay. I'll pull it now, guys. Okay, guys, let's start. So first of all, sorry for the delay. So I was stuck in the rain. So okay, let's start, guys. So today we'll discuss about next hop cell. So first of all, why we require this command? Anybody has any idea why we require this command? Next hop cell, and in which scenario we require this command? So any idea?
The non-client, if we create and root that's BGP, the next hop client, next hop server will be 16.6.
That you have seen yesterday route reflector, but in the normal scenario, when you use next hop cell. So let us consider we have R1, which is an autonomous system number 1. We have R2 and we have R3. So which is in autonomous system number 20. So now, so let us consider between R1 and R2 we have 192.168.12.0/24. This is dot 1, this is dot 2. So this is 192.168.23.0/24. This is dot 2 and this is dot 3. Let us consider we are advertising a network 1.1.1/32. Now, whenever any eBGP neighbor advertises anything to iBGP, this iBGP while advertising to another iBGP neighbor, it will not change the next hop. So for R3, if you check the BGP table, show IP BGP. So 1.1.1 network will be pointing to the next hop 192.168.12.1. So now, but if you talk about R3 from R3's perspective, who is the next hop? Next hop is 23.2, not 12.1. So you need to go to R2. You need to go under BGP. So neighbor IP, that is R3's IP, that is 192.168.23.3, and next hop self. You need to tell. So for R3 to reach to 1.1.1.1, you need to use me as the next hop. Clear? This is one problem with what is a iBGP. So we'll see how to implement this next hop self now. The same problem was happened yesterday when we used route reflector. Even unit because eBGP neighbor was what is sending the updates to the route reflector, so that's why it was not changing the next hop. So same we'll see with another scenario. So let us take 3 routers. And the same you can implement in the route reflector, yesterday's lab. So R1 is an autonomous system number 1. And R2 and R3 are in autonomous system number ESF 23. So now let us consider R1 has a loop back 1.1.1.1/32. And the IP address between R1 and R2 will be 192.168.12.0/24. And the IP address between R2 and R3 will be 192.168.23.0. So wait for the console. So let us configure the IP and the BGP neighborship in the node. So on R1, interface is 0/0. IP address will be 192.168.12.1/20. No shut. Interface loopback. IP address will be 1.1.1.1/30. So router BGP 1. BGP router ID will be 1.1.1.1. So neighbor 192.168.12.2. What is the remote AS? Remote AS will be 23. Advertise the loopback using the network command. That is 1.1.1.1. Specify the mask. That is slash. Done. This is the configuration on R1. So on R2, so interface G0/0 will be 192.168.12.2. One more interface, that is interface G0/1. So IP address will be 192.168.23. You don't have a loopback here. So router BGP 20. BGP router ID will be 2.2.2. Neighbor 192.168.12.1. Remote AS will be 1. And we have one more neighbor. That is with R3. 192.168.23.3. And remote AS will be 20. Yeah? Now final configuration on R1. So interface G0/0. The IP address will be 192.168.23.3. Router BGP 23. So BGP router ID will be 3.3.3.3. We have one neighbor, IBGP neighbor. That is 192.168.23.2. Remote AS will be 20. Done. So just copy paste. So on R1, on R2, okay. R2, so Wait for the adjacency. So we have neighbor. So on R2, you should see two neighbors. One with R1 and one with R2. Show IP BGP summary. We have two neighborships, one with R1 and one with R3. R3. On R2, we have one neighborship with R1 and one neighborship with R3. Now, if we check the BGP table, show IP BGP. Network has not been advertised in R1. Show run pipe section BGP. We have advertised show IP interface 3. And we have a loopback as well. Wow, why it is not advertising? Just a deal. Wait. Yeah. What is the next stop? 12.1. Now, if you go and check on R3, what should be next stop? Same 12.1. Show IPv6. Can you see the problem here? What is the next stop? It is 12.1. But what it should be? It must be R2. R2's Z0 bar 1 interface, not R1's Z0 bar 0 interface. So the problem is, whenever any eBGP neighbor advertises to the iBGP neighbor, then that iBGP neighbor will not change the next hop while advertising to another iBGP neighbor. So now you need to go to R2 and implement next hop cell towards the neighbor R3. How to do that? It's a valid route, but it is not selected as the best route. Why? Because I don't know how to reach to next hop. It is 12.1.
So in this case also, do we have reachability till 1.1?
Tell me.
Even we in this case we have next hop 12.1. We have reachability from R3 to 1.1.1.
R3 to 1.1.1?
Yes.
No, I didn't get you.
Is it able to ping 1.1.1 from R3?
No.
Okay.
How?
Okay.
Because I don't know 12.0 network. I know my next hop. Who is my next hop? That is 23.
23.3.
Yes. That is the problem.
Okay.
So now if you go to R2 and configure next hop cell, then so go to router BGP 23. Sorry, not 232. Neighbor 192.168.23.3. The command is next hop cell. Enter. Now go to R3. So clear IP BGP stack. Now if you check BGP table. Now can you see who is my next hop? 23. I know my next hop. That's why it has installed it as the best path. Even if you check in the routing table, we'll have this route in the routing table. And even you have don't have reachability. Why?
Need to make a static route.
Tell me.
So need to make a static route.
Not required.
Advertise this network.
No, it must reach, right? I don't know how to reach to 12.1. No, man. Go to R2. .0 is not advertised, sir. Okay. The problem is R3 doesn't know how to reach to 12.0. If you check show IP route, can you see? I don't have the route to 12.0. So you can create a static route, or you can go to R2 and advertise 12.0 as well. Clear? Go to R2. This is one layer. So you can go to R2 and advertise 12.0. Router 23 network 192.168.12.0 mask. So go to R3, check the BGP table. IP 0.0, try to pay. Show IP route. What is the next stop? 23.2. I know how to reach also. So what about R1? Just wait.
So it's between different AS number should not be advertised redistribute.
Redistributor, no, not required of redistribution. No, why you require redistribution?
We're using different AS number.
That is for EHRP,
Okay.
not here. That is link local. That is local address. That is not at all. The problem is R1 doesn't know how to come to 23.0. Go to R3. You go to pin. That's the reachability problem. Can you see now? That's the reachability problem. There is no requirement of redistribution here. I hope this part is clear. It was a reachability problem, guys. Clear? What next option? So now we'll discuss about Confederation. So now, what do you mean by Confederation? So this is another way in order to avoid your full mesh IBGP adjacencies. This is another way, just like your route reflector. To avoid full mesh IBGP adjacencies. First difference between confederation and route reflector is confederation is little bit difficult to implement compared to your route reflector. So if you talk about route reflector, the only changes you need to make is on the route reflector server. But in configuration, there is so much configurations to do. So let us consider this topology. We have R1, we have R2, we have R3, and we have R4. So how many full mesh adjacencies required? 6, right? So that is n into n minus 1 by 2. 4 into 3 by 2. So we require 6 adjacencies. As the routers goes on increasing, then your full mesh IBGP adjacencies also goes on increasing. So in this case, what we can do is we can configure confederation. So how to do that? Let us consider the autonomous system number as 120. Now how the confederation works. So it's up to you to, what do you say, bind the routers in a particular sub autonomous system numbers. So in confederation, we create sub ASs. So, but for the outside world, let us consider we have one more router here, R5. So for the outside world, there is only, all the routers are in the single AS, that is AS 123. So for R5, these all 4 routers are in the single autonomous system number. But with the confederation, we will be creating sub ASs. So R1 and R3 will be in one sub autonomous system number AS 13, and R2 and R4 will be in one sub autonomous system number, that is AS 20. So with 6 full mesh adjacencies, we'll reduce to 4 adjacencies. So it's up to you how you, what do you say, make these sub autonomous system numbers. You can put either 2 routers, 3 routers. So maximum is 2 or 3. You can use even 4 routers as well. It's up to you. But again, if 3 routers comes into the picture, then again full mesh. Correct? The same, yes, same like your IBGP and EBGP it works. So let us consider we have 3 routers here. So let us consider the autonomous system number 23. So now if you create sub AS here, now what is the problem again? Again, you need a full mesh, right? Every router should be connected to every other router. Again, or you can use route reflector with confederation. So this is one task. This is one major issue with confederation. Clear? It depends on the requirement, what you use. Either you can use route reflector or you can use confederation, depending on your requirement. But if you talk about the configuration part, route reflector is very simple. But now I'll show you the configuration for confederation, how to do that. This concept is clear. So inside, so this is again same. It works like a EBGP neighbor, and this IBGP neighbor. Everything will be same, but we call this as confed internal, and we call this as EBGP as confed external. Only this is the difference. Rest everything follows the same. EBGP multi-pop. If you're forming adjacency between EBGP, you need to provide EBGP multi-pop. Rest everything falls same. Clear? But for the outside world, all these routers are located inside a single autonomous system, that is 123. They will never be able to see these sub autonomous system numbers. I hope this part is clear. Now we'll see how to configure the configuration. Again, if there are 3 routers, full mesh or route reflector. So you can make R2 as the route reflector, and then you can configure the configuration as well. Little bit hectic. We'll see the configuration. So in configuration, so inside the configuration on each and every router, you need to implement 2 commands under router BGP ASL. So first command is BGP confederation identifier. So this command will identify your main autonomous system number. Identifier. That is 120. So this should be configured on R1, R2, R3, and R4. You should tell who is your main autonomous system number. So this is the first command. Second command is BGP confederation peers. You should tell who is your peer. So for R1, who will be the peer? R2 is the peer, right? So you should tell the autonomous system number of R2. 24. If you are configuring R2, you tell AS number as 30. You need to tell the peers autonomous system numbers. Autonomous system numbers. So these 2 configurations, you need to configure inside all the configuration routers. You need to go to R1, R2, R3, and R4. These two extra commands you need to configure on each and every router. Peer is, let us consider for R1, who is the peer? R2 is the peer, right? So you need to tell his autonomous system number. Sub-autonomous, not the main. Main, you will just notify him once. That is with the identifier. I'm identifying my main as 123. This part is clear. Now we'll see how to configure this confederation. Clear? So we'll take 5 routers. We have R1, R3, R4, and R5. So R1 is in ASL 1. So R2, R3, R4, R5 is in autonomous system number 234. So on every router has a loopback /32 on R1. So IBGP adjacencies will be forming with the help of loopback. And for reachability, we'll be using OSP. And eBGP will be forming with the help of interface IP. So we need to create sub-autonomous systems. So these two are in sub-autonomous system number 23. Correct? These two are in sub-autonomous system number . So the IP address between R1 and R2 will be 192.168.12.0/25. So between R2 and R4, it will be 192.168.24.0. So between R2 and R3, it will be 192.168.23.0. So between R3 and R5, it will be 192.168.35.0. And between R4 and R5, it will be 192.168.45.0. So for reachability, so IBGP, that is ASM 234. So we'll be using OSPF area 0. So on R1, so Z0 bar 0, 12.1, and we have a loopback 1.1.1.1. And router BGP1, BGP router ID will be 1.1.1.1, and neighbor 192.168.12.2, remote AS is 234. Correct? And I advertise the loopback 1.1.1.1 mask /32. Now on R2, so Z0 bar 0 is 192.168.12.2/24, and Z0 bar 1 is 23.2. That is also correct. And then we have one more interface. That is interface Z0 bar 2, and the IP address will be 192.168.24.2/20. So router BGP. So now which ASN I need to use? Should I use 234 or should I use 23? You should use sub AS number. That is router, what is it? AS23. So BGP router ID will be 2.2.2.2. So neighbor 192.168.12.1. What is the remote AS? Remote AS is 1. So we have one more neighbor, so, but this time IBGP adjacency will be forming with the help of loop bands. So neighbor 3.3.3.3. What is the remote AS? Remote AS is 23. Correct? And you need to update the source. Neighbor 3.3.3.3. Update source. Done. We have one more neighbor, that is 4.4.4.4. What is the remote AS? Remote AS will be 40. Enter. Update the source. Plug 0 and eBGP multi-hop, because we are forming a eBGP neighborship here. Different autonomous system number, right? So we require a eBGP. Why we require eBGP multi-hop? No. Yes, online guys. Why we require eBGP multi-hop here?
TTL is one
Very good.
in
Very good.
ABG.
Very good. Super. So TTL value. So if we talk about eBGP TTL, it is by default 1. eBGP multi-hop, we'll change the multi-hop to 2. Done. So this is the configuration on R2, but you need to add 2 more commands here. So this is a normal configuration, how you do. Normally, how you establish IBGP and eBGP adjacency. So for the configuration, you need to add 2 more commands. First command is BGP confederation identifier. This is used in order to identify your main autonomous system number. That is, 234. And second command is BGP confederation PL. That is 44. Clear? This is the configuration of R2. So you need to add these 2 commands on each and every router. Clear, Vinod? It's going over the top. Understanding, right? Okay. So R3. So Z0 bar 0 will be 23.3 and Z0 bar 1 will be 35.3. We don't have Z0 bar. So router BGP 23. So BGP router ID will be 3.3.3.3. So neighbor 192.168. Sorry, not. So just quickly remove this. So neighbor. So I have one neighbor with 2.2.2.2. So what is the remote AS? Remote AS will be 23. Correct? Neighbor 2.2.2.2. You need to update the source. Back 0. And we have one more neighbor, that is 5.5.5.5. Remote AS will be 45. You need to update the source. Back 0 and eBGP multi-hop. So BGP configuration identifier will be 234 and PR will be again same 45. So now go to R4. So R4 G0 bar 0 will be 24.4 and Z0 bar 1 will be 45.4. So router BGP 45. What is the BGP router ID? 4.4.4. So have adjacency with 2.2.2.2. Remote AS is 23 and have updated the source to loopbacks. And have one more adjacency with 5.5.5.5. It is remote AS 45. Update the source and I don't require multi-hop here. I require multi-hop for 2.2.2. Don't get confused. This is for neighbor. Huh? So BGP configuration identifier is 234 and peer is 20. Easy, right? So this many configuration you have to do. So on R5. So before that, still we didn't provide the reachability. So we need to establish OSPF between R2, R4, R3, and R5. So on R5, so Z0 bar 0 will be 192.168.35.5 and Z0 bar 1 will be 45.5. So router BGP 45, BGP router ID will be 5.5.5.5 and neighbor 3.3.3.3. Remote AS will be 23, update source loopback 0 and eBGP multi-hop. We have one more neighbor, that is 4.4.4.4, update source loopback 0. So identifier is 234 and peer is 23. Now inside iBGP provide the reachability. So go to R2 and enable OSPF. Now where I should enable OSPF? On Z0 bar 1 and Z0 bar inside iBGP. The command is IPOSPF1 IPOSPF1 area 0 interface command. You can enable OSPF under the interface as well. Area 0, just copy paste everywhere. So Z0 bar 2. Even we cannot configure the loop back. Shabash. Address slash 30. On R2, I have enabled OSPF1, Z0 bar 1, Z0 bar 2, and on the loop back as well. Clear? Now go to R3. So now enable OSPF. On R3, you need to enable OSPF on all the interfaces. On Z0 bar 0, on Z0 bar 1, and on the loop back. Now go to R4. Create the loopback and enable OSP. This is the command. Happy OSP of 1. Yes. Then on R4. Now final on R5. So interface loopback. What is the IP address? IP address will be 5.5.5.5/32 and enable OSP. This much configuration you need to do inside the what to say IBGP. Which one? No, I'm forming with the help of. We'll advertise one more loopback. We'll create one more loopback on R5. First, everything is clear. First, we'll see 1.1.1.1 on all the routers. Then we'll go to R5 and we'll create one more loopback and then we'll advertise under BGP. Clear? So now, so any doubts with the configuration? Yes, online guys, any doubts? Govind, Darshan, Kavana, Ranjita, Suhas. Any doubts, guys? Wow, I hope it is clear. Okay. So now we'll copy paste. So everybody is clear. Wow, man. Then task is required. No doubts. So after this, one small task. I give you a task, you can perform and what is it? It's for your practice. I'm not sure. It's up to you. If you practice, it will be good. Okay. So don't submit and all, but just for your practice. Nothing, just extend one router extra. Then you can use both route reflector and confederation in one lab. Both the labs in one, 2 in 1. So R1, R2, R3, R4, so go to R1. No? Go to R2. Commands are correct. Yeah, I will share code. So on R3, so on R4, have configuration peer and configuration identifier is clear, right? Only those extra comments. Rest everything is same. How you configure IBGP and EBGP neighborship. On it will automatically take the loop back. So let me go to R5. First check the reachability. Show IP, OSPF, neighbor. Two-way. What happens in two-way state? You know what happens in two-way state? OSPF. Yes. What happens in full state at least? Yes, mother. What happens in two-way state in OSPF?
It exchanges hello packet.
In
And
two-way state,
yeah,
Oh, the routing tables are converged. It's done.
routing tables are converged in two-way state.
no,
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 sorry,
two-way
not-
state. Just they will exchange.
That's what I was expecting.
Hello.
Two-way, this one, a DRBDR election. In full state, then full adjacency, and then they will exchange their routing information with the help of DBD packet. Is DBD reliable or unreliable? Why?
In extract state, right? I mean DRBDR election.
No, in two-way state, DRBDR. Extract state, master and slave.
Okay.
Exchange state, DBD. Loading state, what you say? Your LSR and LSU. And then we have full adjacency. Clear? Okay, come back. BGP. Show IP BGP. Summary. I have two adjacencies. One with R3 and one with R4. Let me ping to 2.2.2.2. Should have reachability? It is fine. So OSPF is working fine. Now, so go to R1. So advertise the loopback, right? Show IP BGP. So I have loopback advertise 1.1.1.1. So go to R2. Check. Show IP BGP. Show IP. 12.1. Next up is 12.1, correct? So go to R3. Sorry. Show IP. Why this problem? Again, the next hop self. Because whenever eBGP enable advertise to R2, R2 will not change the next hop. So go to R2 and use next hops. So router, this you need to take care of. But that's why BGP seems to be tough, right? So these are all the things that these are all the challenges. So you need to know when to use next hop self, when to use eBGP multi-hop. So few challenges. When to use update source loopback 0. So if you know this, then BGP will be easy for you. 23. So neighbor 192.168. Sorry, I have formed with the loopback 3.3.3.3. Next hop set. No, why you require eBGP? eBGP election. Just check. Go to R4 and check. So before that, we clear this. So clear IP BGP star sub. Show IP BGP. Now it has changed the next hop to 2.2.2. So go to R4. So R4, check the BGP table. Show IP BGP. So now one more question for you. So this is the wrong entry. Don't worry about this because this is the eBGP adjacency. It should choose 2.2.2.2. Why it is not choosing 5.5.5.5? It has two paths, right? So why it is choosing 2.2.2.2? Why not 5.5.5.5? Yes, guys.
Least hop count.
Hop count? No. Please check the lab. Guys, BGP's first feature. Least ace path, no Govind, no Manoj. Next stop reachability. No. Oh, BGP is almost came to end. Always what the router prefers. This is eBGP. This is iBGP. And it will always prefer eBGP over iBGP. Why? Depending on the administrative distance.
the least best path.
It's not least best path. Admits AD value. Always, why we use BGP? Mostly we prefer BGP for external routes rather than internal routes. Okay, let's continue. Okay, so final check on our show IP BGP. Fine. Again, a problem here. What is the problem? Who is my next stop? Should it choose 4.4.4.4 or 3.3.3.3? eBGP or IPGP? So you need to change the next stop. So, but since we have reachability, just go to R3 and R4. You can change the next stop. So even if you change the next stop, it will choose 3.3.3.3. Because why? eBGP. Let's go to R3 and R4. Yes. Router BGP 23. So neighbor 5.5.5.5. Next hop 7. So go to R4. Both are eBGP, right? So go to router BGP 48. Neighbor 5.5.5.5. Next hop 7. Let's go to R5. Clear it. One more problem is there with the Confederation. I'll tell you what. So clear IP BGP star. Huh? Show IP BGP. Can you see now? Let's change the next stop. Why it is preferring 3.3.3.3? Because of the eBGP adjacency. So always eBGP is preferred over IPGP. Clear? Now the problem is will not be able to pay. Because in Confederation, what it says is until and unless I have a source in my BGP table, I will not be able to reach to the desired destination. Now, what do you mean by that? Now, so you need to go to R5 and create a loopback. So interface loopback 1. So IP address, let us consider 55.55.55.55 / enter. I need to go under BGP. Router BGP 40. Advertise the network 55. Mask. That's that. Done. Now show IP. Now ping 1.1.1.1. Use the source. Must ping. Wait for it. It reaches to R1. Wait. So let it advertise. BGP is slow, guys. You need to wait. Show IP. Wait for the advertisement. 55 is gone here. So go to R2 and check once, and then to R1. Must ping. I have 55. So go to R1. I got 55. Next stop is 12. Now why it is not ping? Must ping. So sorry, loopback 0 not, it's loopback. I told you. Confederation is that's my problem. So this is one more key point. Please make a note. Until and unless you have your source inside the BGP table, so you will not be having reachability. So you need to create one more loopback, then advertise under BGP, and then check the reachability. So until and unless the another what is the source with which we are pinging is inside the BGP table. It will not ping. So you need to go under BGP. You need to create one more loopback. Go under BGP and then need to initiate the ping. Clear? So this is about confederations. Yes, everywhere inside the confederation. R2 and R3. So you need to create one more loopback. Otherwise, see, just go to R3. Okay, we'll prove Madan's point as well. So let's go to R3 and try to initiate a ping. .1.1.1. I'm unable to reach. Now create one loop. So interface loop back. So IP address will be 33.33.33.33 slash. So go under router BGP 23 advertise the network. So 33.33 mask slash 32. Now 1.1.1.1 source. So this is one key. Source should be located in your BGP table. I hope this part is clear. So anybody has any doubts with the configuration, they can ask me. No doubts? Clear configuration? So okay, take one task. If you practice the lab, it will come. But so task is for you to do. So please finish the task. Just take one more routers everywhere. So this is your task. I will not ask for submission, but please practice because it will going to end by Sunday. So one more announcement I need to do. Let me finish this. So R2.
Maybe BGP we have in the CCNP route.
This is CCNP only. No, I didn't get you. Means CCNP route.
What all syllabus will cover in CCNP? This is NRC, right?
Both route and NRC.
So is that only BGP included or anything else you will cover?
Then no, this is only EHRP is there, BGP is there, OSPF is there. I completed OSPF and EHRP. This is the last topic that is BGP. So now your task is you need to create sub ASs. 2 sub ASs. So this is an ASN 1. This is an ASN. I can take 234. So take this as ASN 2 and this as ASN 3. So IPs, you know already 12.0, 25. So smaller number and bigger out. So this is your task. So do it yourself. No need to submit. You can just use it for practice. So again in R2, R3, R4, you need to configure route reflectors here. Or you need to use full mesh. So IBGP, you need to have either full mesh or route reflector. Otherwise, your routes will not be exchanged. I hope this part is clear. So okay, we'll take a quick break. We'll come back.
Is RR for, can you show the diagram you deleted? Control Z.
No, I didn't get yes. Tell me.
No, the diagram which you plotted.
Yes.
Yeah. Is
Yes.
R3 is RR for R2 and R4?
Yes, correct.
And R6 is R5 and R7, right?
Yes, you are right. Okay, so I'll come back by 9:40. So we have one more small topic we'll discuss and we'll finish up. So one more request I need to make. So tomorrow I'm on emergency leave. I need to travel somewhere. So I'm requesting all of you that we'll have a session on Sunday, if you guys are okay. Sunday 1 hour, only 1 hour I need to discuss one more topic, that is NAT and PAT. So if you guys are okay, I will discuss about the attributes as well. Attributes with the lab. We have 4 attributes to discuss. Major attributes, that is weight, local preference, AS path prepending, and MED. So I need at least 1.5 hours of class because I need to discuss NAT and PAT and about the BGP attributes. So actually these will be taught in CCI Enterprise, but still if you guys want, I will just show you these labs as well. Yes, guys, tell me. Yes, Vinod Mother. Okay, Govind is okay. What about others, guys?
Sunday same time, sir?
Yes, tell me.
Sunday same time?
Sunday we'll have a little bit early. Is it okay?
Yes,
because
okay.
I have a session at 10 o'clock.
Yeah, we have also 10 o'clock another session.
Oh,
so
then you are joining my session only? Is it switching?
No, sir. That's I think Palo Alto.
Palo Alto. Okay. So then
Yeah, you can do it.
Shall we
8
start
or
at 7:30 like that? So we'll end by 8:45 or 9.
no issue, sir. That's fine.
No issues, sir. What about others, guys? Sunita?
No issues,
No
sir.
issues. Okay.
At what time?
At 7:30? Is it fine?
Okay.
Or if you want at 8, that is also fine. Because I will come as if I will come to the institute because my new batch is starting on that day. So I need just 1 hour, 1.5 hours. So that I will finish off this. So there is only 2 topics left. Now I will finish off with PBR, policy-based routing. So then we are left with NAT and PAT. Attributes, it is not there in the syllabus. It is there, but very briefly. But if you guys want, I will show you the labs as well. Just a quick small.
Policy base is a part of BGP or
No,
separate
no,
topic?
not part of BGP. So BGP is done.
Okay.
Is it fine, guys? One more topic. Aggregation. I hope you're talking about aggregation, Manoj. Yeah. SI query, SI reply. Oh, we will discuss that on Sunday. Sure. I'll discuss on that. Is it okay for everyone? 8 o'clock we'll meet on Sunday then. Okay.
So tomorrow is class or directly?
Tomorrow we don't have class. We'll have directly class on Sunday.
Sunday, okay.
Saturday, that's why I told you emergency. I'm traveling tomorrow.
Okay,
Tomorrow
no
on day.
problem.
Clear? So now we'll finish off with aggregation and PBR as well. If possible, I will take on Sunday. 2 hours or maximum 1.5 hours. Clear, guys? Is it okay? Everybody is okay with that?
So Sunday we should start at 7:30, sir.
7:30 will start or 8? You tell me. You tell me, guys. 7:30 or 8 is fine for you. Yes, Balaji, Darshan, Kavana, Magalingam.
Yes, sir, no problem.
No problem, right? Okay, Balaji. Anything is fine. Okay, we'll start at 7:30.
And any time is okay. Just
okay, Darshan. Okay, fine. 7:30 we'll start, guys. So we'll have a 2-hour session. So in that, what all we'll be covering? So we will be covering NAT and PAT. So attributes as well. So in this, we'll be covering 4 attributes. We have weight, local preference, AS path prepending, and we have MED, multi-exit discriminator. So that 4 attributes, and then we have SI query and SI reply. There is no lab for SI query, SI reply, just the theory part. Clear? So these 3 concepts will finish on Sunday. Please guys adjust because emergency tomorrow. So that's why I'm leaving to some place. So today, so before ending, we'll finish off with aggregation in BGP with suppress map and unsuppressed map. So there are 2 maps called suppress and unsuppressed. So we'll see. So we'll see till 10 o'clock how much it happens. So if everything is fine, then we'll discuss about this PBR or we'll take this session also on Sunday. Okay, we'll see. Just take a quick break. We'll come back, guys. So 9:45. I think we'll finish with aggregation and stop. PBR we'll discuss on Sunday. Fine. Start with aggregation. So aggregation is same like your summarization. What you do in EHRP and OSPF. So the same thing applies here. So what are the advantages of aggregation? Yes. Reduce the size of the routing table. Less CPU usage. Less memory. And link flaps will not affect the neighbors routing table. So now we'll see how to do aggregation in BGP. So let us consider we have two routers. We have R1 in ASN1 and R2 in ASN2. So this will be 12.0/24. Let us consider we have 4 loopbacks: 172.16.0.0/24, 172.16.1.0/24. We have 172.16.2.0/24, and we have 172.16.3.0/24. Now we'll see how to aggregate the routes on R1. And then we'll see suppress map and unsuppress map. Let's take two routers. So ASM1, ASM. So between R and R2, 192.168.0/20. Then we have 4 loopbacks on R1, 172.16.0.0/24, 172.16.1.0/24, and we have 172.16.2.0/24 and 172.16.3.0/24. So on R1, so interface 0/0 will be 12.1, and we have 4 loopbacks, that is 172.16.0.1/24. We have interface loopback 1. IP address will be 172.16.1.1/24. We have loopback 2, 172.16.2.1/24, and loopback 3. So IP address will be 172.16.3.1/24. Done. So on R2, we have only one interface. We don't require this. So 12.2. So just wait. Just copy paste. Now R2 as well. So now go to R1 and enable BGP. Router 1, BGP router ID 1.1.1.1. Neighbor 192.168.12.2. What is the remote AS? Remote AS will be. So advertise the loopbacks. That is 172.16.0.0 mask /20. 1.0, 2.0, 3.0. Show IPVGP. Why? Didn't enable BGP in R2. Router BGP router ID. Neighbor 192.168.12.1. What is the remote is? Remote is okay. Wait for the adjacency. Done. So show IPVGP. I have an adjacency. Show IPVGP. Why next stop is 0.0.0.0? Self originate. Just wait. What is the by default keep alive? Time of BGP. What is the hold on time? Yes. 10:40. No. You're talking about OSPF. BMA network. Yes, guys. It's online. What is the BGP keep alive and hold on timer by default? Just
180 seconds.
Is it a hold on or a keep alive?
Keep alive is 60
Keep alive is?
seconds. 60 seconds.
Very good. Keep alive is 60 and hold on time is 180 seconds. Clear? Show IPVGP. 4 loopbacks with the next stop 12. Now we'll see how to do aggregation on R1. So you need to go under BGP. Router BGP 1. The command is aggregate address. Then you need to specify the summary IP. That is 172.16.0.0 and the summary mask. What is the summary mask here? 255. 255 dot. No.
252.
252. Why? 4 block size. 252.0. So now again here one more problem with BGP. I'll tell you what. We're done aggregation. Now, if you go and check the BGP table, good Govind, it's 60 and 180. Now go and check on R2. Can you see? It has done aggregation, but it is advertising the loopbacks as well. So if you do only aggregation on R1, then it will send the aggregation with the loopback IP as well. So you need to go to R1 again. You need to use summary only command. So this is one extra thing you need to add in BGP. Otherwise, what BGP will do? BGP will send the aggregated routes with the loopbacks as well. Enter. Now, when you use this keyword, that is summary only, now it will send only the summarized route. Go and check on R2. Can you see? Now we have only one single summary. So this is mandatory. This is mandatory command. You need to use summary only keyword. Please make a note. If you only use this command, it will send the aggregated route. With the aggregated route, it will send the loopbacks information as well. So in BGP, you need to use summary only keyword just to send the summarized routes. So now how it avoids the loops? By creating a null zero route. Even the BGP will also create a null zero. Can you see? It has created a null zero. Why it is null zero? Just to avoid the loops. What is the metric? 5. 2 points, don't fall. I hope this part is clear. This is how we do aggregation. Only single command, aggregate hyphen address, summary IP and the summary mask, then summary only. If you don't use summary only command, it will send the aggregated routes with the loopback IPs. Now, with this aggregation, you can do two things. One is, can use suppress map, and you can use unsuppress map. You can use either of the one. So these two mechanisms are used to leak the routes. So now what do you mean by suppress map? So let us consider, I don't want to advertise first and the last loop. So you can use either suppress map or either you can use unsuppress map. I don't want these two routes to be leaked to R2, but I want to leak these two routes. I want to send 1.0 and I want to send 2.0. So if you use suppress map, then you need to suppress these two loopbacks. If you use unsuppress map, what is mean unsuppress? Means I want to send the information. I don't want to suppress the information. Then with the help of unsuppress map, you can send these two loopbacks information. Not clear? Yes, suppress means I don't want to advertise these two. I will use suppress map matching these two IP addresses. It is opposite of suppress map. Yes. Clear? Now how to use that? So you need to go to R1. First, you need to create a access list. So access hyphen list 1, I want to permit. What I want to permit? I want to permit 172.16.0.0. Route map will take the actions. Okay, this is used just as a selector. Clear? 0.0.255. Enter. Then I want to restrict 172.16.3.0. 0.0.255. Right? Sorry. So access list 1, permit. So I want to permit 172.16.0.0.0.0. I want to select this route and I want to select 172.16.3.0. Now it's up to you. Now let us consider I want to use suppress map. Means I want to suppress both of these routes. Then go and create a route map. Route map, Cisco. Okay. Enter. So match IP address according to loopback 1. Then allow the rest, that is 20. Now, so go to router BGP 1, aggregate address. What is aggregate address? 172.16.0.0, 255.255.252.0, and with this you can use suppress map. So now you need to attach the route map name. So what is the route map name? Route map name is Cisco. and summary only. So now what this command is saying. Now if you check show run pipe section BGP. So now what this command will do. So this command first it will aggregate. So it will aggregate and it will send only the summarized route and then it will check the suppress map now. Now what suppress map is saying? Check the what do you mean suppress map? That is your route. Show run pipe section route. So what your route map is saying? So you need to suppress what? You need to suppress whatever you have matched in the access list. Clear? Now, so now what access list is saying? Show run pipe section access. So you need to suppress these two routes and you need to allow 1.0 and 2.0. Now, if you go and check on R2, so on R2, start. So it should allow 1.0 and 2.0. What is the problem? Method aggregate. Use suppress map. Yes. Permit only because correct. Then if I deny here, then what is the use of this suppress map? Just to select the routes. So that with suppress map, no, there is no other option to attach. You can't use a prefix list or access list to attach. There is only route map to attach this. Okay, guys, I'll check this. No problem. We'll discuss this on Sunday. Okay. I'll check this. So keep a hold on this suppress and unsuppress. So this aggregation is clear. Suppress and unsuppress I'll discuss on Sunday only. Clear? So this is the rest of the routes. It should allow, right? It should allow this 1.0 and 2.0. So now it has matched it has matched the access list.
Access list we have that permitting.
No, this is acting as a selector here, right? So he is taking the actions. Route map is taking the actions. Okay, guys. So we'll meet on Monday. So we'll discuss these two topics as well: suppress and unsuppress. Clear? Okay, guys. So we'll end up today. We'll continue on Sunday. So please do join on Sunday. So we'll have 1.5 hour session on Sunday. So we'll discuss the rest of the topics. 7:30, guys. Okay. Okay. Bye, guys. Have a nice day.